Hello guys, welcome back to Maths on African Motives. Still on our O-level revisions. In this case, we shall be focusing on our psychogeometry, which is one of the most important topics that we have in our syllabus that we are supposed to understand the basics. So in this case, we shall be answering the questions. I just hope we managed to check the first part, the introduction, working with the theorems and so forth. So we've got typical exam questions that we are going to work with from this part. We've got the first part of our question. In the diagram A, B, C, and D are points on the circumference of a circle. So we've got these points A, B, C, and D on the circumference of a circle. So meaning to say the whole of the shape that we are seeing here is going to be a cyclic quadrilateral. Remember that a cyclic quadrilateral, all the vertices will be on the circumference of a circle, point A, point B, point C, and point D. So these are some of the things that you're supposed to take note. And also we are given that PD is a tangent. So we are given a tangent. Remember the concept of a tangent, that angle between a tangent and a chord. There's an angle here between a tangent and a chord. So you can just name it in short, tan chord. In short, tan chord. An angle between what? A tangent and a chord. That is the angle between this tangent and the chord. DC in this case will give us the angle at the circumference, that is the angle at A. And also if you check the chord, DC is creating the angle at B. So these are some of the things that you're supposed to take out whilst you are reading the information. So that means automatically if this angle is 47, this one is going to be 47. This one also is going to be 47. The other reason that we can see that this angle will be 47 is they are created by the same chord. DC is creating the angle at B and also creating the angle at the circumference at A. So we understand that angle subtended by the same chord in the same segment, that they'll be equal. So if this is 47, this is 47. All right, then again, from this information, you can see that we are given a diameter. AD is a diameter. So you know that a diameter subtends an angle of 90 degrees at the circumference of the circle. So meaning to say the angle at C here is going to be what? 90 degrees. Angle created by a diameter at the circumference of a circle. All right, let me try to reduce this a little bit. So this is going to be what? This is going to be 90 degrees. So we are having 90 degrees at this point, created by a diameter. These are some of the things that we just have to understand before you even attempt your questions. So the first part of our question was to calculate the angle BAD. All right, that's BAD. B to A to D, the whole of this angle here, the whole of this angle BAD, that is the angle here, B to A to D. Take note, the 47, it's not for BAD. The 47, it's for DAC, this angle here. This is the one for that we are indicating as 47. Now they want us to calculate BA to D, the whole of this angle here. That is the one that we are supposed to calculate. How are we going to calculate this angle? What is going to be the concept in this case? So if we are to check here, we are saying we have got a diameter in this case that created this diameter here. It created the angle at C, which is 90. Also, this diameter AD is creating the angle at B. If we check our diameter AB, it's creating the angle at B. So meaning to say also this angle at B here is going to be what? Is going to be 90 degrees. So if the angle at B is going to give us 90 degrees, then that means we can calculate the whole of this angle at what? At A, the whole of this angle, which is the one that we are asked to calculate. We can be able to calculate this from which concept? We can subtract this angle, the 28, the 90, and the 47 from 180, or simply the 90 and the 28. So that your angles from 180. So like I was saying, you can just consider these two angles. The 28 and the 90 is just one and the same thing. So we are going to have our angle BAD in this case as 180 degrees minus the 28 degrees and the 90 degrees that we have in this case. All right, we subtract these two angles. Since we are to calculate the angle, this whole A. We are not involving this 47. If you include the 47, it means you are going to remain with this piece here. If you include this 47, you are going to remain with this piece here. So after finding this piece, you are going to combine these two. That is what you're going to do. But in this case, we can simply calculate this angle at once from subtracting this from 180, these two angles that we have. So this is going to give us 62 degrees at the end. So meaning say the whole of this angle at A, the whole of that angle that we are seeing there is going to give us what? It's going to give us 62 degrees. And also the other thing, if you are given a triangle, you want to calculate a right angle triangle always. When you are given a right angle triangle, you want to calculate the third angle given another angle, like let's say this is 28 degrees, like the one that we are given there, 28 degrees. We want to calculate the remaining angle. Instead of us subtracting 180 minus 28 plus 9, you can simply say, since we know that in a triangle, these angles, they add up to 180 degrees. Already we have removed 90, the right angle there. So meaning to say these two angles, they are going to add up to 90. These two angles, they are complementary. They add up to 90 degrees because if you say 180 minus 90, we remain with what? With 90. So if these two angles, they add up to 90, I can simply subtract 90 degrees minus this 28. I'm obtaining the remaining angle, which is going to simply give me 62 degrees. So that's another part that we can simply work with, where as long as we are dealing with the right angle triangle. Let us know this part for the basics of our revision. All right, anyways, let us see the other part, CDP. All right, so that is CDP. We already found this one. We said this CDP is going to be 47 from the tan chord concept. Angle between a tangent and a chord is equal to the angle in the alternate segment. CAB, that's C to A to B. All right, C to A to B, that is this remaining angle here that we have. Remember, we said the whole of this angle at A is 62. And this part, another part of A here, it's 47. So we are going to subtract 62 degrees minus 47 degrees. So that is going to give us something like 15 degrees. All right, so that was our angle. Then we move on to B, CD, that is B, C to D. Take note, they want us to find the whole of this angle here, the whole of this angle, B, C, D. Remember, we have the whole of the angle at A, which is 62, and we like I said before, that this is a cyclic part. Since all the vertices are on the circumference of a circle, all the vertices are on the circumference of a circle. So we're referring to a cyclic quadrilateral, whereby in a cyclic quadrilateral, opposite angles, they add up to 180. The angle, the whole of this angle at A, which is DA, DAB, and BCD. These two angles, they must give us what? 180. So we're simply going to subtract 180 minus the 62 degrees at A. So we are subtracting the angle at A, which is 62 degrees. So that was going to give us 118 degrees in this case. All right, so that was our question. Let's see the other part. We are given another circle again. As you can see, that's a cyclic quadrilateral. We are already given here that this is a cyclic quadrilateral for the vertices on the circumference of a circle. This is M. This is C, this is B, this point was A, this point was D. And we are given angle MBC 70 degrees. So this angle here is 70 degrees MBC. And we are given this angle of 40 degrees in this case inside here. That is 40 degrees. And this is the center of the circle. All right, like we can see, there's a center. So you know that definitely there's a diameter. So a diameter here is going to subtend an angle of what? 90 degrees at the circumference. So we know that this angle is going to be 90. Also, the diameter is subtending the angle at C, which is going to be 90 degrees. And also, we can prove that from our cyclic quad. We know that opposite angles of a cyclic quadrilateral, they are supplementary. They add up to 180. So 90, this 90 here, and this 90 here added up together, they give us 118. So that is another part. And also, if we take here, we can also find, all right, let's answer the questions. The other ones we see as we're answering. Find ECD. All right, first part, that is a BCD. So already BCD, we found this one. We said it's 90 degrees from the concept of what? A diameter subtending an angle of 90 degrees at the circumference. All right, that was our BCD. Then we've got ABD. ABD, this angle here. All right, what can we do to find this angle ABD? If we are to consider what we have here, there are actually two options that we are having here. There are actually two options that we can work with. The first option is to find the angle, this angle here. First option is to find, we can find the angle at B. If we want, we can find this angle at B. From which concept? We know that angles in a triangle, they adapt to 180. And like I said, if you know this concept and you know that this is 90 degrees, you must know that these two remaining angles should give us what? 90. So to find the angle at B is going to be 90 minus 40, which is going to be 50 degrees. Or you simply subtract 180 minus 90 plus 40. Still one and the same thing. So having 50 degrees on this angle, we are going to now find the angle at what? The remaining angle, because we know that here we are having what? A straight line. We take into consideration here, we are talking about what? A straight line. A, B to M is a tangent. I mean, this line is being produced too. So it's a straight line. So angles on a straight line add up to 180. So I'm going to simply find angle ABD by subtracting this remaining, these two angles from what? From 180. So it's going to be 180 minus 70 degrees plus 50 degrees in this case. All right, so if we subtract, we're going to have 180 minus 70 plus 50, something like 120. That is going to be 120 degrees. So if we subtract, we are going to obtain 60 degrees. So meaning to say this angle here is going to give us 60 degrees. That's the angle ABD. All right, so that was the way that we could have calculated this angle. Another way that we could have used, but now I'm seeing that they are actually asking, we could have calculated this angle first, but now I'm seeing that they are even asking this angle here, ADO. So that was the way that we could have used. But if in case that you used it this way, then you wanted the same thing. All right, now they're asking us to calculate ADO. So there were two options that we could have used to calculate this ADO. One, we've got this 70 here, which is the exterior angle of a cyclic quad, because this line was being produced, so we are having exterior angle. And we know that the exterior angle of a cyclic quad is equal to the opposite interior. This is our interior angle, this one. This is the interior angle. But we are talking about the opposite, the one that faces the interior angle, which is this one. So it is equal to the whole of the angle at T, the whole of this angle at T. So if 70 is the whole of angle D, therefore you can simply subtract the 40 degrees that we have here from the 70. So it's going to be 70 minus 40, which is going to give us what? Which is going to give us 30 degrees. That was another way. So if you are using this 60 degrees now, if you are using this triangle, let's say you didn't see this part of 70 degrees and you want to use what? You want to use this triangle. How are you going to find this angle at T? You are simply going to subtract. Since this is a right angle triangle, we said this angle is 90. So we are going to subtract 90 minus what? 90 minus 60, because I said the remaining angles on a right angled triangle, they add up to what? They add up to 90. So we're going to subtract 90 degrees minus 60 degrees, which was simply going to give us the same angle of what? 30 degrees. That is the idea here. So this angle was going to be 30 degrees. All right, let's check another part. On this information we're given in the diagram, all right, we put these points and so forth and so forth. All right, angle, center of, where's the diagram? That is our diagram here on top. So this is the information that we are given on this diagram. We're given this angle of 64 degrees. Here we've got the angle of 64 degrees. So the first question from this angle was to calculate, that was the first item, was to calculate GH. All right, so what are we going to see? Let us consider our diagram first. From our diagram, we've got parallel lines and we've got a center. Remember, this becomes a diameter, and I said a diameter subtends an angle of 90 degrees at the circumference. So meaning this to say this angle here at the circumference is going to be what? 90 degrees. Also from the concept of parallel lines, we can see that this angle here, the angle at H, is going to be the same as the angle at what? As the angle at J. We are creating what here? We are creating Z angles, which are alternate angles in this case. All right. From the cyclic part concept, you can see that these points H, I, J, and G, they are on the these 4 points are on the circumference of the circle. So this becomes a cyclic quadrilateral. So it can work that this exterior angle of 64 is equal to the opposite interior. This is the interior, but the opposite one, that is the opposite interior. So we are referring to the angle at what? The angle at G. So the angle at G is going to be 64 degrees. All right. So these are some of the things that we can consider parallel lines. Also, to see that from O to H and from O to J, these two are equal in length. We're talking about a radius. Also from O to J and from O to G, these two are equal. We're talking about the radius concept. Angles on a straight line, we can find this angle at I here because we are given angles, we are given a straight line. So by simply subtracting the angle of 64 from 180 degrees, we can even find this angle, which is going to give us 160 degrees. Study your diagram. It's important just to study your diagram. Yes, you can attempt your question, this and that, but just learn to study the diagram. All right, anyways, let us answer our question. The first angle was JGH, which is this one from J to G to H, which is 64 degrees. Where did we find this angle? From that exterior angle equal to the opposite interior. All right, so that was the first angle that we are given. Let's quickly rush through and see the next. All right, so the other one, it's GHJ and HJI. All right, so these are the remaining angles. As we can see, let's see. So the remaining angle that we are supposed to calculate on the B part was GHJ. All right, so how are we going to have this angle from G to H to J? That is this angle here. Remember, I said this angle and this angle, they are equal. But how can we find this one first? All right, if we said the angle at G here, it's 90 degrees from a right angle formed by a diameter. And I said once you have a right angle triangle, it means these remaining angles, they must give us what? They must give us 90 degrees. So meaning to say, we are simply going to subtract 64 degrees from what? From 90. So it's just going to be 90 minus, which is going to be 26 degrees. Or you subtract 180 degrees minus 90 plus 64. It's one and the same concept, one and the same thing. Just understand, guys, we have a right angle triangle. So we can just shorten this part, all right? Then the other angle, as we saw, it was to calculate angle HJI in this case. All right, so that is from H here to J to I here. Remember, we said these two angles are equal. So if this angle is 26, it means also this angle is 26 from what? From the parallel lines concept, we are creating a Z, we are creating alternate angles. So you are supposed to know also the properties of parallel lines. This is geometry. Understand every concept of lines, every concept of shapes, every concept of angles, how angles are related. That is geometry. Before we talk about the circle geometry, you're supposed to know the geometry first on itself. All right. Then we are given another question. In this case, we are given in the diagram. Again, we've got a cyclic quadrilateral in which AB is equal to AD. So let's check AB and AD. These are chords, chord AB and chord AB. So sometimes they might give us the arc AD and the arc AB is the same. We apply the same concept there. What we are supposed to understand is that equal chords or equal arcs, they subtend equal angles at the circumference. So if you hold the chord AD, it's creating an angle of C. The angle that it is creating here is going to be the same as the angle created by the chord AB. Equal chords, they subtend what? Equal angles. So this angle and this angle, they are equal. The same thing we are given that BC is equal to DC. that is from B to C. And so meaning to say we have the same concept again. Chord here, DC, is creating the angle at A. So the angle at A is going to be equal to the angle created by the chord BC. The chord BC is creating also the angle here at point A. So these two angles, they are going to be equal, created by equal chords, not by the same chord, but by equal chords. Yes, we have our same chord like on a condition like this part of AB. AB here is creating an angle at D. It's also creating an angle at C. This one is from the same chord, not from equal chords. So that the part that makes this angle D to be equal to angle C, which is 10 degrees, it's not because of equal chords. No, it's because they are subtended by the same chord AB or the same angle. The chord that is creating at angle D is the same chord creating the angle at what? At B. So these ones is from the same chord. But for these ones to be equal, we say it's from what? Equal chords. These chords, they are equal, not that to say they are on it is the same chord. No, they are just equal. So they have the same properties as what the same chord does. All right. So meaning to say, if we say this is 10, remember I said these two angles are equal. So it means also this angle here is going to be 10. That is how we play around circle geometry. All right, let us answer our questions. The A part, state the special name given to the cyclic quadrilateral ABCD. As you can see, these two sides are equal. These two sides are equal. So this is a kite. So also the angles here, this angle, this angle, this angle, it is bisecting the angle. So these are the properties of what? Of a kite in this case, all right? So we move on to the other part now. Find angle ACD. All right, that is the B part. Find first part ACD, that is from A to C to D. Remember, we say this one and this one, they are equal from the 10 degrees that is at D. It is the same as the angle at C and also the same. So meaning to say this angle is going to be 10 degrees. ADC from A to D to C. We want to find the whole of this angle here, ADC. Which concept are we going to take, or which idea are we going to take to find ADC in this case? All right. If we take note on our information, we are told here that AC is a diameter. AC is the diameter of the circle. We are told, we are not seeing the center, but we are told that AC is the diameter. So if AC here is representing the diameter, what does it mean? It means it is going to subtend an angle of 90 degrees. Also is going to subtend an angle of 90 degrees at D. So that means the angle at D automatically is going to be 90 degrees. Angle subtended by a diameter, which is the same as the angle at B. Automatically, this angle is going to be what? 90 degrees. Angle subtended by what? By a diameter. At the circumference, it's going to give us what? 90 degrees. All right, so that was the part of our question. Then on this one, we are given a circle, in this case, in the diagram above A, B, C, points on the circumference of a circle center O, and we're given the angle AOC, which is 3y, and ABC, which is 4y, ABC. Okay, so these are the two angles that we are given. Then the first part of our question, let's check. Our first part of our question was, write down an expression in terms of y for reflex AOC, all right, for the reflex AOC. Then item 2, find the value of y. All right, so let us check. First one, we want to calculate or to find the angle in terms of y for the reflex AOC. This is the reflex angle. Remember the properties. That's why I said, guys, geometry, you need also to know the properties. If you're dealing with the geometry, you need also to know the properties of shape, the properties of shapes. From our geometry, we know that from our angle concept, this angle can be an acute angle, it can be an obtuse angle. But the one that is on the outer side, this one is the one that represents what? A reflex angle. We are talking about a reflex angle there. So from the center concept, angles are completed here in a complete revolution should give us what? 360. So it means if we are to combine the two angles, we are supposed to obtain 360 degrees. So in terms of y, it means our reflex, in this case AOC, reflex AOC is going to be what? 360 degrees minus the 3y that we are given, the angle that is inside. If this angle was 120, we are going to subtract. If this angle was 130, we are going to say 360 minus 130. If this angle was 150, 360 minus 150. But this angle now is given as 3y. So it's going to be 360 degrees minus what? Minus 3y. So that is an expression for reflex AOC in terms of what? In terms of y. Then the other item was to calculate the value of y. Now, in order for you to calculate the value of y, you are supposed to formulate an equation. You are supposed to have an equation from two things that you know that they are equal. From our theorems, is there any part that we can equate that can give us an equation to say this part and this part, they are equal? Remember, we know that the angle that is at the center is twice the angle at the circumference. If we are dealing with this one, if we are dealing with the angle of AOC, this 3y here, the angle that it must affect is this one at the circumference, the one that we are going to have at the end, at the circumference like this. This is the angle that it must be affecting. This one, not the 4y plus 4. The 4y plus 4 is affected by this angle here. This is the one that affects 4y plus 4. So if we are saying the angle at the center in this case, which is 360 minus 3y, is equal to, it's an equation that you are forming there. The angle at the center is equal to what? 2 times the angle at the circumference, or twice the angle at the circumference. That's 2 times 4y plus 4. That's forming an equation. This is equal to 2 times this. Meaning to say, for this to be equal, you must multiply this by 2. For these two to be equal, that's forming an equation. And you can solve for y in this case. All right, so you can just expand our brackets. 360 minus 3y is equal to 2 times 4. That will be 8y plus 2 times 4, which is 8. Collect your like terms. So you can take the 8 to the other side, so that we're going to have 360 minus 8 is equal to, take 3y to this side. It's a negative, so it's going to be a positive. So that one is going to be 8y plus 3y. So if we subtract 360 minus 8, that was going to give us 352. And 8 plus 3, that's 11y. Divide by 11 so that we obtain the value of y here. So that means y is going to give us what at the end? The value of y is going to give us 11 into 35. That is going to be into 33. It's going to be 3 times into 33. Having a remainder of what? Having a remainder of 2. 35 minus 33. Then 11 into 22, that is going to be a 2. So meaning to say y was going to give us 32. Just 32 in this case, as we are given y. They're just saying y. So in terms of angle, that will be 32 degrees. But just for the value of y, you can just write it as what? As 32. All right, so that is how they might play around our questions. So we managed to answer this part of finding the value of y. Let us check the other part of our question we are given. That's again, we've got a cyclic quad. If you check our points, they're all on the circumference of a circle. So we are given that on this circle, we've got center O. So the moment we've got center O, that means we've got a diameter AOC that becomes a diameter. And I said a diameter subtends an angle of 90 degrees at the circumference, an angle of 90 degrees at the circumference. So meaning to say the angle subtended at B here, the whole of the angle that is subtended at B is going to be 90 degrees. The whole of the angle subtended at A, the whole of this angle at A is going at D, sorry, is going to be 90 degrees. That is subtended by what? A diameter. A diameter is creating an angle at D. A diameter is creating an angle at B. So just understand this concept, all right? Then we move on to the other part. We've got the parallel lines. As we can see, we are given OD is parallel to BC. OD and BC, they are parallel. So from parallel lines, we understand again this issue of alternate angles and so forth. So you know that this angle at D, this piece here, and this piece if you are to create here, we can see that we are creating a Z. So that means this piece and this piece here will be equal the other piece at what? At B. All right, so that was the idea of our information in this case. So this angle is given as 30 degrees. So let us see. Calculate ODB. All right, that is O to D to B, this one. ODB, this one that I indicated from our parallels, this one. ODB, this one. Okay, we say this angle and this angle, they are equal, which is true. But where can we find the angle now? Let's take note about the 30. What is happening with the 30 degrees, this angle of 30 degrees? Which chord is creating this angle? If we are to take note here, the chord CD or DC is creating an angle here at A. And we know that the same chord must create the same angle at the circumference like this. So meaning to say angle at A is the same as angle at B. So if this angle is 30, this angle also is going to be 30. And remember, I said the angle at B is the same as the angle at D from what? From the parallel lines concept. They are creating what? A Z. They are creating a Z. That is, we are talking about alternate angles in this case. So meaning to say these two, they are equal. So this angle was going to be 30 degrees. All right. So that was our angle. Let us check another part, ABD. All right, that's angle AB to D. All right, AB to D, this one, AB to D. All right, take note, we are talking about this one that is remaining here, that is ABD, A, B to D. But remember what I said about the diameter. A diameter is subtending an angle of 90 degrees. The whole of the angle at B, it's 90 degrees. So if the whole of this angle at B is 90 degrees, how am I going to find the remaining angle ABD? I'm just going to subtract from what? From 90 from 30. So it's going to be 30 from 90 degrees, which is going to be 60 degrees. So this angle is going to give us 60 degrees from the concept that the whole of the angle at B, it's 90 degrees created by a diameter. All right, then we've got ACB in this case, ACB from A to C to B. That is this angle remaining here, the CB. Where are we going to obtain this angle from? All right, if we take into consideration from our parallel lines, we can see that we are creating also a Z here. We are creating alternate angles, that is a Z, all right, from this B. If we go straight to C, we got this side to O and back to D. We are also talking about a Z angle created at this point and created at this point, meaning to say the angle that we have at O and the angle at C, they'll be equal. These two angles, they'll be equal from what? From the parallel lines concept. But how can we find the angle at O? All right, to find the angle at O, let's consider what is happening with the DC. It's creating an angle at O. The same chord DC is creating an angle or at 30 degrees, which is the same as created at B. So what is the concept about these angles at the circumference and this angle at the circumference? Remember that angle at the center is twice, angle at the center, sorry, this one is twice the angles that are at the circumference. So the angle of 30 times 2 is going to give us this angle, which will be 60 degrees. Angle at the center is twice angle at the circumference. So the moment this angle is 60, it means also this angle is 60 from where now? From the alternate angles concept, Z angles, they are creating a Z. Since these two lines, they are what? They are parallel. So that was the idea on this one. So this angle was going to be 60 degrees. All right, so that was the part of our question. Then here we are also given a diagram. In the diagram, we've got the points P, Q, R, and S. Such points on the circumference of a circle, and we have got a center O. The moment we are given a center, remember what I said, a diameter creates or subtends an angle of 90 degrees at the what? At the circumference. So meaning to say the angle at S, it's 90 degrees there. And also you're given arcs PS and SR are equal. Take note, this time they gave us the arcs being equal, these arcs. But I said, if the arcs are equal, it means also the chords are equal from this concept. If the arcs are equal, the chords also are equal. And what is it that we get from equal chords or equal arcs? It corresponds that what this chord is creating at the circumference is equal to what also this chord is creating at the circumference. So equal chords, they create equal angles at the circumference. So that means this angle at Q is going to be divided into two, this angle and this angle. They are equal. That is the idea there. So here we are given, okay, this angle being 57 degrees. Then the first question was to name, take note here, name the angle which is equal to SQR. That is SQR. As you can see, they are asking this because they know that you are supposed to know that they are taken from equal chords. And we said is what? It's going to be SQP. So the angle equal to this one is going to be SQP. Or you can write as PQS. It's one and the same thing. All right. Find the first item, PQS. PQS, which is the one that we said SQP. It's just one and the same. How are you going to find this? Remember, this is 90 degrees. And I said once you have given a right-angled triangle, these two angles must give us what? 90 degrees. So this one was simply going to be 90 minus 57 degrees. All right. So if we subtract 90 minus 57, this one is going to give us 33 degrees, or you simply subtract 180 minus 90 plus 57 in one bracket. All right, then item 3, QRS. So we now have this angle here. We said this is 33. Try to fill in your diagram also. This is also 33 because we said they are equal. QRS, that is Q to R to S. All right, this angle here, QRS. How are you going to have this angle? If we take note, this is a cyclic quadrilateral. All the vertices are on the circumference of a circle. So what does it mean? It means that opposite angles, they add up to 180. So we are simply going to subtract 57 degrees from 180 because these two angles, they are supplementary, opposite angles of a cyclic quad. So 180 minus 57, that was going to be what? 123 degrees. All right, that was it. QRS. Then we need QSR. QSR. Remember, we said this is 123 degrees. And now we need QSR, that is the remaining angle, this one, the one that is remaining. So on this one, we had two options. Either to use angles in a triangle because we've got two angles in triangle SRQ. We've got two angles, so you know that angles in a triangle, they add up to 180. So we're simply going to subtract these two angles inside the triangle from what? From 180, the angle of 123 degrees plus the angle of what? Of 33 degrees, since we said these two angles are equal. So if we subtract this, we are going to have 180 minus 156. So 180 minus 156 is going to give us 24 degrees. So that was the first option. Or we could have used this idea here, since we are talking about a cyclic quadrilateral and we know that opposite angles of a cyclic quadrilateral are supplementary. So it means we are going to subtract to find our angle QSR. We are going to subtract these angles from 180, the 90, because they are supplementary. So we're going to subtract 180 minus the 90. We are supposed to remove the 90. We are supposed to remove the 33. We are supposed to also remove the 33 because we are saying these angles, they are they add up to 180, the opposite angles. So we are going to subtract from what? From 180, all of these angles. We are still going to obtain the same answer of what? Of 24 degrees. So I want us to try and do this one and see if we are obtaining the same part. All right, then we are given the information that is following here, this point center or this and that, and we are asked to calculate these angles here. This information is from this diagram here. All right, this is the diagram that we are given. So let us just try to analyze our diagram again and see what is happening here. We are given an angle of 42 degrees center O, and like I said, from the center O, a diameter subtends an angle of 90. So the angle at W here is going to be 90. Angle subtended by what? By a diameter at the circumference. And also we are given that these two, they are equal. So it follows that in terms of a triangle, because this chord here is creating the angle at W. So it's going to mean that this angle is equal to the angle that this chord that it is equal to, this angle XY. All right, it has created the angle at W. also this chord here, where is it creating the angle? It's creating the angle at Y, and also it's creating an angle at what? At Z. So it means this angle at Y here, sorry, let me remove this one first. This angle at Y here, and this angle at Z, and this angle, they are all equal from the concept that equal chords subtend equal angles. So if this is 42, it means this is also 42. It means this is also 42 degrees. So these are some of the things that we might play around and have. So let us attempt our questions. Remember the first question, which is our item 1, was to calculate WYX. So what is going to be WYX? That's W here, Y to X. So this one is 42. From this 42, we can take it from the concept that we have got the same chord creating angle here and also creating angle here. So we said these two angles, they'll be equal from the same chord. So that will be 42 degrees. And the other angle was asked there was to calculate that is YWZ, all right, YW to Z, which is Y to W to Z, okay, YW to Z, that is this one that is remaining here. Remember, we said this angle is 42, and this angle at W is 90. The whole of angle at W is 90 from the diameter. So these two angles added up, they must give us 90. So we are simply going to subtract the 42 degrees from what? From 90, because these two angles must give us what? Must give us a 90 degrees in this case. That is going to be our angle Y W to Z. So you are supposed to be careful. You are supposed to be very careful on your attempt in this case. So that was going to give us something like 48 degrees in this case. All right. But if it was YWX, YWX is going to be what? Is going to be 42 in this case. All right. Let me check. Is this the same angle that we asked there? All right. That's YWZ, and WXY, the other one is now WXY. All right, that's WXY in this case. Where are we going to have WXY? That is from W to X to Y. That is this angle here. This is the one that we are referring to, WXY. So remember, we said here, these two angles are equal, and we are talking about a triangle in this case. So angles in a triangle should give us what? 180 degrees. So that means in order for us to calculate WXY, we are simply going to subtract from 180 degrees minus these two angles, that is 42 degrees plus 42 degrees in this case. So that was going to give us 180 minus 84 degrees. 180 minus 84, that is going to be 96 degrees. So that means here the whole of this angle is 96. And here we obtained 48 degrees. So there are so many ways that you can actually answer as long you are using the theorems. What is important is that, are you applying your theorems? Are you applying your theorems? That's the most important part. In the diagram, we are given that B, C, and D, A are points on the circumference of the circle. All right, so, and the tangent in this case. So remember, from our tangent concept, angle between a tangent and a chord is going to be equal to the angle in the opposite segment. This chord is creating the angle at C. So these two angles, they will be equal. The angle of 40 degrees, right? This angle of 40 degrees here, this angle that we see of 40 degrees, and this angle that is on the other side, these two, they'll be equal. So if this is 40, this also is going to be 40 degrees from our tan chord, angle between a tangent and a chord. And also we are given that this is a center from our center, O. It means EC is a diameter, and I said a diameter subtends an angle of 90 degrees at the circumference. So it means the angle that is created here at B, the whole of this angle B is going to give us 90 degrees. The whole of this angle B is going to give us 90 degrees. But we have the 67 here that we are given. So it means we can find this one that is remaining here, because we are saying the whole of this angle is what? It's 90. So if we are to subtract 90 minus 67, we are going to obtain something like 23 degrees here. Also, if you check, we have got the chord here. If we join from D to E, there's a chord there. This chord is creating the angle at B. The same chord is creating the angle at what? At C. So what do we know about this part? We know that the same chord subtend equal angles at the circumference. So if this is 23, it means also this angle is going to be 23 at the circumference. There are so many things. If you consider here, also the 67, since here we have a line, it means this angle is going to be 67 degrees from the chord that is creating this angle, that is also creating an angle of 67 degrees. So this one will be 67, this angle here from D to E to C. You can make adjustments just to fit in some values, and it means also this one here was going to be 90 degrees, that is EDC. So that is what we have. Let us try to attempt our questions here. Let's see what we are given. Calculate EBD. All right, that's EBD. That is this 23. Remember, we calculated this 23 from concept that this is 90 degrees. So we simply subtract 67 from 90. So we calculated this one. It was 23 degrees. BCE, that is BC to E. We also calculated this one. We said it's 40 from the tan chord theorem, tangent and a chord. BEC, that is B to E to C. We want this angle that is remaining here. How are we going to find this? Remember, we're talking about angles in a triangle, and this is a right-angled triangle. There's a 90 degrees here, so it means these two angles must add up to 90. So you're simply subtracting 90 minus 40 degrees, which is going to be 50 degrees. So this angle here is going to be 50 degrees. All right, that's 50 degrees. Then the other angle is BDC. BDC. So let's check where are we having BDC. That is from B to D to C. That is this angle that is remaining here, BDC. Remember, we said the whole of this angle combining here is 90, not this one. This one is not 90 BDC, but we can take it from the chord BC. The chord BC is creating an angle at D. It is also creating an angle at E. So it means this angle at E is supposed to be equal to the angle at what? At D. So this is going to be 50 degrees. Also, we are referring to angles that are subtended by the same chord. Psychogeometry, guys, revise your theorems, work with your theorems, understand your theorems. All right, then we've got another circle here that we are supposed to consider. All right, let's see what we have here. That's we've got the point A. In this case, this is A, this is B, that's O, and this is C. And we are given this is 7, and the angle here is 60 degrees. This is 60 degrees, all right? So let's just hope it's clear. This angle here is 60 degrees, all right? So our question was, in the diagram, points A, B, and B and C are on the circumference of a circle center O. So we've got a center O, meaning to say from O to A, this side is equal from O to B. So if this is 7, this means it's also 7. We're talking about the radius concept here. And since we also have a center here, it means also the angle at the circumference is half. Remember, angle at the center is twice the angle at the circumference from the chord AB. It's creating the angle at the center. The same chord AB is creating angle at the what? At the center. So meaning to say this is going to be half of the one that is at the center. So 60 divided by 2, we are going to have 30 degrees there. All right, so let's see our questions. Take pi to be 22/7, meaning to say we are supposed to be working with mensuration of plane shapes, in that case, or so forth. Calculate the angle ACB. ACB, already calculated this one. We said 30 degrees from the radius concept. From the angle at the center to the angle at the circumference. OAB, that is OA to B, this angle here. How are we going to find this angle? Remember, I said from the radius concept from O to B and from O to A, these two are equal. And we know that opposite, the sides that are equal sides they give us equal angles on a triangle, opposite angles. That to say this side, it is opposite to this angle. This side here, it's opposite to this angle. So these two angles, they are equal. So if they are equal, we can simply subtract this angle of 60 degrees in triangle OAB. We are dealing with this triangle OAB. So we can subtract this angle to find angle OAB. We can subtract 180 minus 60 degrees. Then whatever that we get, we divide by 2. Since these two angles are equal, so 180 minus 60 was going to give us 120 divided by 2, which is going to give us 60 degrees. So this angle is 60, this angle is 60 degrees. So what does it tell us? It tells us this is actually an equilateral triangle because we've got 60, 60, 60 in this case. So meaning to say also AB is equal to OA, it is equal to OB. This one we got it not because of the radius concept, no, because of the angles that are formulated. We are obtaining 60, 60. So it's an equilateral triangle. So meaning to say also if these two sides are equal, also they're equal to this because the angles are equal in that case. All right. So then the C part was to calculate the length of the minor arc AB. We're talking about this arc AB. This is the minor arc, the one that is subtended by the smaller angle of 60 degrees. Remember, we also have arc AB. This one, it's arc AB, but this is the major arc. The bigger arc is the major arc. So they want us to calculate for the minor arc. Take note, length of arc. It's a minor, but talking of what? Arc. We are talking about the length of arc. How do you calculate the length of arc? Remember that length of arc is equal to what? Theta over 360 times 2 pi r. We are back now to your mensuration of plane shapes, whereby we are saying an arc is simply a piece of a circle. It's a part of a circle taken from the angle that is subtending at the center, which is 60 degrees. So that's going to be 60 over 360. Let's just use this one without a degree. It does not affect over 360 times 2 times. Always use the pi that you are given. The given pi is 22 over 7 times the radius. In this case, our radius here is what? It's 7. So here it's just you guys and your mathematical skills. 60 here, that's 160 into 360 is going to be what? 6 times. Is that so? The 0 and the 0 cancel there. And you can reduce by 2, that's 1 here, by 2, that's 3. So as we can see, we are left with nothing to be reduced in this case. So we can simply combine. It's going to be 22 on top over 3. So we're going to remain with the 22 over 3. 22 over 3, which is same as 3 into 22. That is going to be into 21 7 times. Remainder 1 over 3. Length of arc is measured in unit centimeters. In this case, we are not talking about area. Area, that would be square centimeters, but length of arc is just like from a circle. From a circle, we are talking about the circumference. So length of arc, it's a piece that is being taken from our circle. So that's why we use theta over 360. Then the D part was to calculate the area of the minor sector A or B. So we are calculating the area of the sector in this case. So as we know that the sector, it's simply a piece that is taken from the circle again. So in this case, they want us to calculate the area of the minor sector in this case, which is AOD. So as you can see, truly, we are formulating a sector. If we are to take note here, this is a sector that is being formed. So in order for us to calculate the area of the sector, as we are saying that it's a piece of a circle that we are taking. So the area is going to be given as theta over 360 times pi r squared this time. Remember, this one is from area of a circle. So this one, a piece of a circle. This one, we're talking about the circumference of a circle. Length of arc is taken from the circumference of a circle. We are just taking a piece from there. So that's why we use theta over 360 times the circumference of a circle. But a sector now, we are talking about a complete part whereby we are now calculating the area, whereby we are now calculating the area of the sector. So once you know these properties, you just have to understand that a circle and a sector is just one and the same thing. So all you needed here is to substitute our values. Remember, we have our radius, so we're just going to substitute. So our area Sorry, let me reduce this one. Let's have our area now. Substituting our values is going to be theta, which is 60 degrees. So that's 60 over 360 times pi. Remember, we use the given pi, which is 22 over 7 times the radius. Our radius there, it's 7 squared. So remember, it's radius squared. So it's going to be 7 squared. So it's now you and your simplification, reduce your numbers properly. You are going to obtain something like 77 over 3, which is going to give us 25 and 2 over 3. This is now area measured in what? In square centimeters. That is the idea for the area in this case. So as you are dealing with the sector, it's just a piece of a circle that you are having. Then on the other part, we are given that is in the triangle. In the diagram, we are given P, Q, R, and S are points on the circumference of a circle. All right. Then we've got the information PT. PT, this is our P, this is our T, and we have got this, our S, our R here, in this case, our Q, and center O. And these chords, these two, they are equal. And this angle is SQP 72. This angle inside here, it's 72 degrees. All right. So that is what we're given in this case. And remember what I said from our sides which are equal. In this case, we are not going to say yes, we can use that, say it's subtend, yes, subtend, but what you can see that the angle at S is going to be equal to the whole of the angle at what? At P, the opposite one from our triangle concept in this case. But if we are to use even the chords, we are saying the chord SQ is subtending angle at what? At P, all right? The chord PQ is subtending angle at what? At S. So meaning to say these two angles, they are supposed to be equal. And if we take note again from our tangents, I said if you are given two tangents from the circle where they meet at this point T, these two tangents, they are going to be equal in length. So meaning to say from S to T and from P to T, these two are equal. And also we know that from our radius concept, a radius from O, because O is the center, O here is the center. So we know that from a radius concept, if we are to join from O to P, which is to the tangent, the angle created there is going to be 90 degrees. And also from O to S, if we are to join like this, from O to S like this, the angle that is going to be created here is going to be 90 degrees. So there are so many things that we can actually consider and make constructions on our diagram. And if we know this, then it means this angle at O, this angle at O here, and this angle at T should give us 180 degrees. Why? We are talking about the whole quadrilateral must give us 360, but we are saying this one is 90 from O to S to T, from O to P to T, it's 90. So we have covered 180 degrees out of the 360. So 360 minus 180, we obtain what? 180. So these two remaining angles, they are supplementary. They must give us what? 180. All right, so there are so many ways. Okay, let us see. Calculate PSQ. PSQ, that is they are referring to this angle, the whole of this angle at inside PSQ, the one that is inside here, the one that we said it is equal to the angle at P. So what are you simply going to do? From we subtract this 72 from 180, we simply divide by 2 because these two angles, remember we said they are what? They are equal. So we are going to simply subtract. So our PSQ was going to be 180 degrees minus 72 degrees, but we have to divide by 2. So that was going to give us 108 over 2, which is 2 into 10, that is 5 into 8, that is 4. So this angle is 54 degrees, meaning to say also this whole angle here is going to be 54 degrees inside what? Inside S. All right, then we move on to SRP. SRP, this angle that is remaining here. All right, this angle from the chord SP is creating the angle at Q. All right, the same SP here, it's creating angle at what? At S. So you understand that equal chord, the same chord subtend equal angles at the circumference. So this angle is going to be 72 degrees at the circumference. So here we can simply subtract our angles. All right, so SRP, we said we're gonna take this as what? As 72. All right, sorry for that. Then we've got SPR, that is S to P to R in this case, which is this one that is remaining here. SPR, this one. All right, from S to P to R. So we are referring to this angle. How are we gonna calculate this? If we are to take note here, we can say this angle, we can subtract this one from the 72 degrees, or we can say that since this whole of this angle is 54, what about the remaining one that is going to affect the 54 on this other side? All right, what is going to be the remaining angle? But here we understand that we have got a radius, and we said, okay, let me explain from this way. I think this one can be easier for you to understand this circle. There's a lot. Let me increase here so that you understand me here. If you check on this part, we have got a diameter here, this one, from R, this point here from R to P. This one is a diameter, okay? Having this diameter RP, it's creating an angle of 90 degrees here at S. It's creating an angle of 90 degrees. So if it is creating an angle of 90 degrees here, this one, it means we are going to subtract this 72 that we said it is equal to this angle. And this 90 from 180, we remain with this angle that we want. I hope we are together. This angle here is 90 degrees. It's a right angle subtended by a diameter like this. It's creating 90 degrees. But this angle here, is 72. So we have got an angle of 90, the whole of this, and this 72. So if we subtract these two angles, they are going to give us what? The angle SPR. So meaning to say our angle SPR was going to be 180 minus these two angles. We said 90 plus 72 degrees. All right, so if we subtract these two angles, we are going to obtain 18 degrees. So this one was going to give us 18 degrees at the end. So that was the idea of our question. We're going to obtain 18 degrees there. All right, then what about the item 4, which is PTS? PT to S, that is this one, PTS. Where are we going to have this angle? All right, in this case, with two ways. Remember, I said these angles, this angle is 90, this angle is 90, and I said also these two angles should give us 180. So it's either we are going to find this angle at O, this one, the angle at O here, because I said this one, it's a line joining to the center like this to this one. So meaning to say we've got the angle at the center. So the angle at the center is twice angle at the circumference. So if this is 72, we must multiply that by what? By 2 to obtain the angle at the circumference, which is the 144. So the angle at the circumference was going to give us 144 degrees. But this angle and this angle here, they are all supplementary. They give us 180 because we removed this 90 and 90. Or you're supposed to say 360 degrees minus 90 plus 90 plus the 144 degrees. Still, you're going to obtain the same answer. Or simply, you know that these two angles that are remaining, they give us 180. And also from the kite concept, if we check the properties of a kite, we are creating a kite. These sides from S to O and from O to P, these two sides are equal. And these two sides are equal. These angles, they add up to 180. So you're simply going to subtract 180 degrees minus 144 degrees in this case. So what are we going to obtain from 180? It's supposed to be 36 degrees. All right, so this angle was going to give us 36 degrees. So like I said, it is the same idea that we could have used even if you are working from this side. So let us prove if we are going to have the same answer or the same concept. Then on this part here, we are given, that's in the diagram, A, B, C, and D are on the circumference of a circle, center O, and we are given the tangents and so forth. All right, calculate AEC. All right, AEC in this case, that is from A to E to C, which is this angle here. All right, so if we check, we've got AC, which is our chord creating the angle at D, and also this angle is creating the angle at E. So meaning to say these angles, they'll be equal from the same chord. So this angle is going to be 50 degrees. Then we've got ABC. ABC. If you check here, we are creating or we are having a cyclic quadrilateral, and on a cyclic quadrilateral, opposite angles of a cyclic quadrilateral are supplementary. They add up to 180. So this one was going to be 180 minus 50 degrees, which was going to give us 130 degrees. All right. Then we've got EAF. That is from E to A to F. We've got a tangent in this case. All right. So remember, a radius and a tangent, they meet at 90 degrees. So if they meet at 90 degrees, this whole angle was supposed to be 90 like this. And we have an angle of 20 degrees inside. So we're going to simply subtract 90 minus 20. We remain with what? With 70 degrees. So this one was going to be 70 degrees. Then we've got AEC, that is from A to E to C. Let's check AEC. All right, so no. This is ACE, not A. All right, ACE, that is from A to C to E. That is this angle here. How are we going to obtain this angle? We can simply use the tan chord. Remember, I talked about the tan chord. Angle between a tangent and a chord is going to be the angle in the alternate segment where the chord is creating the angle. This chord, where is it creating the angle? It's creating the angle at C. So if this is 70, it means also this one is going to be 70 degrees from our tan chord theorem. Angle between a tangent and a chord will be equal to the angle that is in the opposite segment in this case. All right, so these are some of the properties that you might be given and so forth. So on this one, we shall end up with this one. We shall see the other ones on our next platform. Like I said, this is the first part. We shall see the second one. So on this part here, we are given that in the diagram, RT and X are on the circumference of a circle, center or the diameter XR. In this case, we're given the diameter XR in this case. All right. So from this information, we're being given to express RTP in terms of Y. That is R to T to P in terms of Y, this angle. That was the first question, to express this angle RTP in terms of Y. So how are we going to have this angle in terms of Y? Remember, we've got a tangent here. So from the tangent that we have, I said angle between a tangent and a chord, this is the chord, is equal to the angle in the opposite or in the alternate segment, where the chord is creating the angle in the circumference. So if this is 2y, then that means this is going to be 2y. So that was going to be 2y in this case. And we are given also to find the value of y on the item 2, what was to find the value of y. So to find the value of y, what is going to be the concept? I said whenever you are to find the value of the unknown, you are supposed to formulate an equation from the statement which is true. You are supposed to formulate an equation. All right, we know that here it's a diameter. We're given that the diameter is XR in this case, and we know that a diameter subtends an angle of 90 degrees. So that means the angle that is created here is 90 degrees. Knowing this, that this angle is 90 degrees, and we are given the whole triangle TPX, we have got the whole triangle and everything on this triangle is given, and we know that angles in a triangle, they add up to 180 degrees. So with this concept, you can create an equation to say, if we add these angles, if we add y, all right, we are going to combine every angle. If we add y plus this 2y here, plus the 90 degrees that is here, plus the 2y that is on this side here, everything must give us 180 degrees. We are talking about angles in a what? In a triangle. So you can collect like terms. This is same as 1y. So we're going to add 1 plus 2 plus 2, which is going to be 5y, is equal to 90. To this side, that will be 180 minus 90, which is going to give us 90. So we can divide by 5 in this case. So thus we have the value of y. So 5 into this, it was going to give us 18. So meaning to say y is equivalent to 18 degrees. Wherever we see this y, it represents what? 18 degrees. So if you put back the y where there is a y there and you simplify, every statement must be true about what we have been referring or what we've been talking about. So like I said, this is going to be the first part. Let us continue to revise as much questions as we can. Shall meet again with the second part of this platform. But if there are any other questions, let us know so that we can simply attempt that specific question. But for the basics, which are important in our psychogeometry, know the theorems, revise your theorems as much as you can. That is the basics of your psychogeometry.